Before we get too far into trig ratios, I just want to take a moment to make sure that we understand that you should be copying down all of the information that I write on each and every slide, not just the amount of information that you'd like to write. That being said, take a moment and press pause and copy all of the information from this slide, including a whole paragraph about what a trigonomic ratio is and the definition of trigonometry, and then this piece right here, the diagram and the trig ratios themselves. Press pause now. Okay, welcome back. Now, what we have are the three trig ratios known as sine, cosine, and tangent. Those are abbreviated as sin, cos, and tan. We're not going to say sin, cos, and tan. We're going to say sine, cosine, and tangent when we read the abbreviations. As you see here, the sine of angle A, so the sine of this given angle right here, is equal to the side opposite A is little a, divided by the hypotenuse C. So the sine of angle A would simply be written as sine of A is equal to A over C. And the cosine of angle A is equal to B over C, because B is the side that's adjacent to angle A. Now the hypotenuse is also adjacent to angle A, but the two sides we're referring to are the legs. So when you see the word side and side, we're referring to the two legs of the right triangle, or any right triangle for that matter. On this slide, we're going to focus on comparing the three trig ratios for angle A in both triangles. So here's our angle A and our angle A. For the larger triangle, the sine of angle A is equal to the opposite over hypotenuse, which is equal to 8 over 15. This is the one time we're going to break from my age-old wisdom of no decimals. 8 divided by 15 is 0.5333. We like to go out 4 decimal places for trig ratios. If you look at the smaller triangle, the sine of A is equal to, again, opposite over hypotenuse, which is equal to 4 over 7.5, which is equal to, you guessed it, 0.5333, which brings us to our statement that the value of a trigonomic ratio, right here, the value of a trigonomic ratio depends only on the measure of the angle itself that you're measuring, not on the particular right triangle. So what we can make an accurate judgment call about angle A is that whatever angle A is here, the measurement of it is the same exact one here, because the sides of each triangle are identical. They're both 0.5333. This magic would also happen for the cosine and the tangent. Feel free to check that on your own. One of the acronyms that can help you remember what the sine, cosine, and tangent are is using the acronym SOHCAHTOA. The S in SOHCAHTOA helps for the sine. So SOH is opposite over hypotenuse. The cosine is the adjacent over hypotenuse. And the tangent is opposite over adjacent. SOHCAHTOA. Say it with me. SOHCAHTOA. What I'd like to do now is just kind of move this out of our way. Draw these up here. And I'd like to evaluate the trig functions for each of the given angles. So we'll start with angle S and the sine function. Remembering that sine, SOHCAHTOA, sine is equal to opposite over hypotenuse, so that's 5 over 13. cosine is equal to adjacent, which is the 12, over hypotenuse, which is 13, and tangent is opposite over adjacent, which would be 5 over 12. Take a moment, press pause, evaluate all of these out to 4 decimal places, and then repeat the process for angle R. Press pause now. Because I was a little short for space on the right side, I merely have the sine, cosine, and tangent evaluated by decimal only. If you take a look now, on our angle S, our sine function is opposite over hypotenuse. What is opposite angle S is adjacent for angle R. So 5 is the opposite side for angle S, but the adjacent side for angle R. So what's the sine function for one angle is the cosine function for the other. And you'll see that happens crisscross for both of those. For the tangent, you won't have answers repeating because they have actual reciprocal fractional answers. This is 5 over 12, and this is 12 over 5. Without spending a ton of time, you should notice something special about the 45-45 right triangle. Right? We have x, x, and radical 2x. No matter what 45-45 right triangle you have, you're always going to have the same trig ratios. For instance, the cosine is going to be 1 divided by the square root of 2, which works out to be 0.7071. And since both legs are the same, then the sine is also 1 over radical 2, which is 0.7071. This ratio is particularly important in pre-calculus. And then, for your tangent, you're going to have opposite over adjacent, which is simply 1. So the tangent of 45 degrees is always equal to 1, and the cosine and sine is always equal to 0.7071. Again, reiterating that it doesn't matter what type of right triangle you have, there's only one cosine and one sine and one tangent for every acute angle that lies somewhere between 0 to 90 degrees. The same can be said for the sine, cosine, and tangent of 30 degrees, and also for the sine, cosine, and tangent of 60 degrees. Take a moment in the book, go to example number 4 when you get into class, and copy in the cosine and sine functions, or feel free to do them on your own now. There are a couple special relationships that we're going to refer to as trigonomic identities. Take a moment to press pause, copy these into your notes along with the diagram, and then give yourself a couple of inches of space in your notes. When I get back into class, we'll work on proving those. Now we're going to use this new trig ratio information to solve some problems. You're measuring the height of a Sitka spruce tree in Alaska. You stand 45 feet from the base of the tree. You measure the angle of elevation to be 59 degrees from the ground to the top of the tree, and you're looking for the height of the tree. When you take a step back and think about all this, we have the adjacent side measurement, we're looking for the opposite side measurement, and we have a given angle. What that sounds like to me is the tangent of an angle, which we'll call theta, because that's what we like to call unknown angles in geometry and in pre-calculus, is equal to the opposite side divided by the adjacent side. Notice, as always, I'm drawing a generic model. Now I'm going to say the tangent of 59 degrees is equal to the opposite side, that's our unknown, h, over 45. Now you need to go to what I believe is page 845. On that page are all of the trig ratios for a given angle. So if you look at the 59 degree mark, or row, you should see that the tangent is 1.6643. 1.6643. And that's equal to h over 45. A little cross multiplication yields us a value of 74.90, or 74.9 feet. That's approximately how tall the tree is. Pretty cool. So now you say to yourself, Mr. Brecklin, this is pretty cool. We could even go to the mall and play with some trig ratios at the mall. I know, it's very exciting. So you go to the mall and you realize that there's some escalators there. The escalator at the Wilshire, Vermont Metro Rail Station in Los Angeles rises 76 feet at an angle of 30 degrees. What we'd like to know is we'd like to find the distance a person travels as they're on the escalator. Riveting information. So what do we have here? A given angle, a hypotenuse, and an opposite side. Sounds like sine of theta is equal to opposite over hypotenuse. So the sine of 30 degrees is equal to 76 over, I don't know. Take a moment, go to the back of the book, page 845, find the sine of 30 degrees, substitute it in, solve for d, and then check the answer. Pause now. Did you get d equals 152 feet? I hope so. You might have even remembered, if you did it on the other page, that the sine of 30 degrees is equal to 1/2, always. On this page, you should be able to go pretty quickly through the first set of questions and just identify with just a fraction what the sine of A is. So for instance, for number 3, the sine of A is equal to opposite, which is 4 over 5. And then just move on answering questions like that. Be ready to answer all these questions, including number 9, in class. In closing, I think what's important is to remember that the trigonomic ratio that we're talking about is the ratio of a given acute angle. It could be sine, cosine, or tangent. No matter how large or small the sides actually are, the trigonomic ratio for any given acute angle is always the same. See you soon.